This is page 3 of our final exam study guide. Starting with number 13, we have a couple of parallel lines cut by a transversal. And we are to find x and y. We can use a couple of things. Just depends on what you see first. I notice that the 3x and the 72 are corresponding angles. And corresponding angles are congruent, so they're the same measure. If I divide by 3, I get that x is 24. So there's my x. Something else to note is that the 72 and y are alternate interior angles, which means that y is 72 degrees. Remember, corresponding angles, alternate interior, alternate exterior angles are all congruent. It's the same side interior angles that add up to be 180. So only two possibilities there. All right, on 14, we need to find x and y. I see a triangle in there, so if I had a little bit more information, I could find the measure of x. Well, I happen to have vertical angles. So I have a 116-degree angle, which means that x plus 116 plus 50 equals 180. Let's go ahead and solve that equation. Whoops, that'd be a 6, yep. Subtract the 166. So x is 14 degrees. And these two are a linear pair. So that means that if I subtract the 50 from 180, I find out that y is 130 degrees. Number 15 asks which two lines are parallel. Probably the most straightforward way to get these without graphing is to put this into slope-intercept form, and then we can read the slope right out of the equation. So let's change every one of these into slope-intercept form. First one, I'm going to divide by 5, and I get y equals negative 2/5 x. Whoops, forgot my x, plus a fifth. The slope on this one is negative 2/5. Second one, need to do a little bit more work to get this one solved. So we'll move that 2x. And then divide through by the negative 5. Negative over negative is a positive. And so the slope of this line is 2/5. They are not the same. And the last one, let's move the 2x. Divide through by 5. And we get y equals 2/5 x. Slope of this line is also 2/5. Since these two are the same, lines 2 and 3 are our parallel lines. Number 16 and 18, we're using the fact that the three angles in a triangle add up to 180. We're also looking at isosceles triangles. Isosceles triangles means two sides are the same, and if the sides are the same, the angles across from them are also the same. So on this first one, we have three angles add up to be 180, and then we solve for x. So x is 48 degrees. We're going to use the same facts for the next one, but a little different results. The angles across from the equal sides are equal. Write our equation. and solve. I'm going to go ahead and subtract that 104. So I get 2x is 76. Divide by 2. X is 38 degrees this time. Both of those use the fact that we have isosceles triangles. All right, number 18 is the last one on this page. It says that Q is equidistant from the sides of that large angle. So we know that these two sides are the same. And because those two distances are the same, these two angles are also the same, or that large angle is bisected. We are looking for the measure of angle QBC. Well, since those two angles are the same, we can set them equal to each other. We'll solve for x, and once we know what x is, we can find the measure of our angle. So we just go through the process of solving for x. And we get x is 10. So now to find the measure of the angle, we're going to plug 10 in for x. Our angle is 22 degrees. And I want to make sure that I'm right. And I know that it has to equal the other angle also. So I'm going to plug it in just to make sure. 20 plus 2 is 22, so it does check. All right, that's the end of page 3. I'm going to download this video, and then we'll start page 4.